Hello, today we are going to talk about Enigma machines. We have been seeing Enigma in popular culture as well. 82 and 2002 made movies are fictions, whereas 2014 made The Imitation Game is based on true stories and true characters. This mentions the life story of Alan Turing and how was the Enigma code was broken. Enigma is mostly adopted by military of Germany in World War II. Enigma consists of two important cryptographic units. One is Rotors and the other one is Blackboard. Also, this area is keyboard and the area above is the display. This guy press A and it's encrypted as B, S10. Let's mention the rotors firstly. S10. There are 3 different rotors in this machine because early versions have 3 rotors. This offers 26 to the power of 3 candidates to the key space. Later versions might have 8 rotors. Rotors can be disassembled and assembled, as seen here. This box stores disassembled rotors. And this capability offers 3 factorial candidates to the key space. Rotors are one of the most important units in the Enigma machine because it applies block ciphers similar to the Vigenère cipher. Its contribution to the key space is 26 to the power of 3 times 3 factorial. But checking all candidates is not a hard problem for today's computation power. It wouldn't contribute to the key space much as seen, but it's important because it provides to be strong ciphers against frequency analyzed attacks. Let's see how rotors work. As seen, there are 3 different rotors and 1 additional reflector. We have skipped the reflector. For this configuration, when you press A, it's encrypted as G, and for this configuration, if you press G, then it would return A as encryption. Reflector provides to become symmetric ciphers. This illustrates for an alphabet consisting of 8 letters. You can see every rotor have 8 inputs and 8 outputs. When you press a button in the time t, the rotor on the right advances 1 position and t plus 1 express the next configuration in the machine. For example, horizontal line exists here at the bottom and it advances 1 position and in the t plus 1 it appears in the first stage. Similarly, this line exists here in the t plus 1 configuration. Pressing a button always advances 1 position on the right and the rotor on the right completes its positions, then the middle rotor advances 1 position. For example, that's the initial configuration, and when you press 1 button, the rotor on the right advances 1 position and it appears as B. When you press 26 letters, then it becomes the last letter on the alphabet, and when you press 1 button again, then the rotor on the middle advances 1 position. This illustration shows how rotors work. The second important cryptographic unit in the Enigma machine is Blackboard. Let's mention it. Early versions have 6 cables and later versions might have 10 cables. And Blackboard provides substitution cipher basically. Notice that Blackboard just applies substitution cipher and substitution cipher is weak against frequency analyzed attacks. Remember that rotors applies block ciphers and block ciphers are strong against frequency analyzed attacks, but rotors wouldn't contribute to key space so much. So Blackboard increases the key space of the Enigma machine dramatically. So Enigma Machine combines block cipher with Rotors and substitution cipher with Blackboard. It has 3 rotors and contribution of the rotors to the key space is 26 to the power of 3. Moreover, rotors can be disassembled and assembled, and changing the locations of the rotors contributes to the key space 3 factorial values. We have 6 cables in the Blackboard, and this means that we can substitute 6 letters. And this is the contribution of the Blackboard to the key space. Here 26 is the number of letters in my alphabet. 26 factorial over, I can substitute 6 letters, that's why 6 factorial exists in the middle. 6 letter will be substituted to another 6 letter, and 26 minus 2 times 6 values wouldn't be substituted. Also 2 to the power of 6 appears here. So contribution of the Blackboard to the key space is more than 10 to the power of 11. Multiplying to the contribution of the rotors and Blackboard is more than 10 to the power of 16. This is a very big number. Assume that you can test 10 to the power of 6 cases in a second. Then you should spend more than 250 years to check all possible candidates. So we have mentioned how Enigma Machine works. Thank you for your attention and see you next time.